Find the values of m for which the equation 2 to the power of mx minus 3 equals 8 to the power of x squared. Has exactly one solution. So depending on what we make this value of m, this equation could have no solutions, it could have one solutions, it could have two, it could have many. So we need to determine which value of m makes this equation have only one solution. So you might be asking, where the heck do I even begin? Great question. Good place to start. At the beginning. When it says things like one solution, immediately springs to my mind is the discriminant, right? If we have a quadratic equation, for there to be one solution, the discriminant must equal 0. So that's if we can boil it down to a quadratic. So yeah, let's see how far that takes us. So we have an exponential equation, but if we're aiming for a quadratic, we need to get the x terms and the m from a power down into the numerator. So let's try and make the bases the same. So right now we have 2 and an 8. So 2 to the power of mx minus 3. 8 can be rewritten as 2 to the power of 3, right? 2 to the power of 3 is 8, but that's all still raised to the power of x squared. All right, and powers of powers we multiply. So that becomes 2 to the power of mx minus 3 equals 2 to the power of 3x squared. Great. Since we have the same bases, we can now just equate the exponents. So mx minus 3 is equal to 3x squared. And this step here uses some log laws, but we don't need to write that. It's implied. Now we can, what should we do? We'll bring everything to the right hand side. So we get 0 equals 3x squared minus mx plus 3. And there we go. We have our quadratic equation that we were looking for, right? We have an a term, b term, and a c term. And so if we want exactly one solution, we will set the discriminant. So discriminant, delta, must equal 0 for one solution. The discriminant is equal to b squared minus 4ac. And in this case, b is negative m, minus 4a is positive 3, c is positive 3. Oh, got the squared, which is negative m squared is m squared, minus 4 times 3 times 3, that's minus 36. And we said the discriminant must equal 0. So m squared minus 36 must equal 0. We can add 36 to both sides. We can square root both sides to get m equals plus or minus 6. So if m is equal to 6 or negative 6 in this initial equation, when we solve it, we could do it graphically, for example, finding the intercepts. There would be only one intercept or one solution for that equation. Right, and we got there by first rewriting 8 in base 2 so that we could then bring the m and the x into the numerator, which gave us a quadratic equation. So that was the critical step, which we were able to then find the discriminant, set equal to 0, and solve for m.